Hi everyone, it's Mr. Hamilton here. You probably know by now how to factor a trinomial. But now we want to know how we could find an unknown value that would make a trinomial factorable. So in this first example that we have, we don't know the b value. The reason I say it's the b value here is if I was below that first example, this is in the general form ax squared plus bx plus c. So that k value there is the b value of the trinomial. And whenever we're trying to factor a trinomial, we want two numbers that add to the middle term, in this case is k, and they multiply to the first term times the last term, which is 5 times 7, or 35. So we need two numbers that multiply to k, that add to k rather, and multiply to 35. Now the way we do that is we simply list factors of 35. In this case, we can go through and we can list 1 and 35. We can list 5 and 7. We can list negative 1 and negative 35, because those multiply to give us positive 35. And we could do negative 5 and negative 7. So there are really four possible factors of 35. Now if we add them up, if we calculate the sum of each of these, 1 plus 35 is 36, 5 plus 7 is 12, negative 1 and negative 35 is negative 36, and negative 5 and negative 7 is negative 12. So really any of these are possible k values, because that is the sum of the factors. And really, that's the answer. So we could say the possible k values are 36, 12, negative 36, and 12, negative 12. Now the second part of it, the second situation that we see, is a little more complicated. And so we need to come up with another strategy to do this. You could use guess and check, but oftentimes it takes a very long time. So the method that we will use seems like there's a lot of steps and a lot to the process, but really it's designed to make it easier. Otherwise we could be guessing and checking all day. So this is probably the most complex situation that we're going to see as far as trying to find an unknown value. But it is a complication that is something that we should be able to deal with, because we've done, as we'll find, this is based on linear relations. So here's our first example, 2x squared plus 11x plus k. We need two numbers that add to the middle term and multiply to the first term times the last term, or a times c. Now the a value is 2 and the last term is k, and so two numbers that add to 11 multiply to 2 times k. Now we have no idea what those two factors can be. So what we're going to do here is I'm just simply going to let my two factors be represented by r and s. So that means that those two factors, r plus s, must add to 11, and those two factors, r times s, must multiply to 2 times k, right? That just follows from the t-chart that we made above. Now let's call this first equation equation 1, and let's call this second equation equation 2. Now I hope you recognize what we have here really is two equations with three unknowns. We don't know the r value, the s value, or the k value. Now we're going to use a strategy in a moment to find that, but if we had had two unknowns, we have two equations with two unknowns. And we solve that, we could use elimination, we could use graphing, but I'm going to use substitution to do that. So I'm going to begin by writing the first equation, equation number 1, in terms of one of the variables. I'm going to rearrange it in terms of r. So instead of r plus s equals 11, r equals 11 minus s. So now what I'm going to do is I'm going to take that and I'm going to substitute into equation 2. So what this means is that rs equals 2k is going to become 11 minus s times s is equal to 2k. Right now I have one equation and I have two unknowns. You can see there I don't know the s value and I don't know the k value. But what I do know is that if I let s be a multiple of this value right here, so in this case a multiple of 2, then it's going to work. I'm going to be able to find something. And you could go on the website if you want to see exactly why that works. But for now, just take my word for it that we need to have one of the factors to be a multiple of the known value of A and C. In this case, the A value is 2. So we need to find, let S be a multiple, in this case, of 2. So let's start with S equals 2. That's just a multiple 1 times 2. So if S equals 2, that means that if we substitute that into the equation, I get 11 minus 2 times 2 is equal to 2 times k, and that becomes 9 times 2, which is equal to 2k, and then we get 18 equals 2k, and if we divide both sides by 2, we get k is equal to 9. If S is equal to 4, we get 11 minus 4 times 4 is equal to 2k, and I get 7 times 4 is equal to 2k. That's 28, and that means dividing by 2 again, that k would be equal to 14. And you can go ahead and use the k value of 9 and the k value of 14 and check and make sure they're factorable, and in fact they are.